Hey everybody, happy Tuesday, hope you're doing well. Turn that down here a little bit. There we go. Alright, we got a couple things on tap today. We're working through chapter 3 this week on types. And then if you hadn't got a chance to finish your lab, I numbered them starting at 0. It'll make sense today. The lab for chapter 2, which is called lab 1. I guess it's a little confusing, my apologies, but they probably should have started the chapters off at 0 as well, because that's just a fun thing to do. So we'll work on that today, and then we're going to talk about on Thursday our first individual project, now that we've got a little bit of practice under our belts here. So, hey, good morning, Trumpet Man. Or afternoon, I know what time it is, right? I think I need a little more coffee, and I don't have my mug with me. I forgot it downstairs. I might have to go run down in a couple minutes and grab that. Or maybe I can get one of my kids to bring it up for me. So, and I already have PyCharm open. Look at that, because I know this thing takes forever. So I'm going to start up a new project for our Chapter 3 examples. And I'm going to put it in my course repository for the class here. So again, all the examples will go online where you can see them here. Oh, you got it, Trumpet Man. I just got a bunch of really good ones here. I just saved a bunch of really good ones. So a friend of mine from high school, he has said he always wanted to be a paleontologist, and he went to school. I don't actually know what you do for undergrad for that, but went and got his PhD, and he's a paleontologist now. I think he teaches at some school in New York, I forget, and does research and stuff. But he was really excited that they found this new dinosaur. What do they call those? It's not like the dig site, wherever they dig. And he said they think they found the biggest lower leg bone they've ever found. And he said it was quite the shindig. All right, so I'm going to blow away all that starter code here. So first we're going to start out with strings. So we've done strings before, right? We said like name was Eric. That's a nice simple string. But there's actually a lot of things that happen behind the scene on strings. So strings are what's known as a sequence type here, and each of these values can be accessed one character at a time, and you do it by index. So when we say the index of, you're saying what position is it at, and with indexes we always start at 0, and that's why the first lab was called lab 0. It's almost all languages will start indexes at 0 for very good reasons. We'll talk about that when we get a little further into our sequence types. But that's index 0, index 1, index 2, and index 3. So there are 4 characters in this string. So if I want to get out a single letter, right, I can do like first initial is equal to, I'll say name, and then square braces is the index of notation. So we'll say name index of, and I can give it 0, will give me just the E out. So I can print my first initial. Print my first initial. Right, so it should print just the E for me, because I'm accessing in this sequence of characters, right? A string is just a bunch of characters all put together here. It's a bunch of them. So I'm getting the 0th index, right? The first index. So we always start at 0. Now, another cool thing you can do with strings is you can get the length of them, right? So len is short for length here. We can say, hey, how many characters are my first name? Right, your first name has... And then we can comma separate, right? Say this many letters. So maybe we'll ask them, right? How about we ask them? How about an input of what's your name? So if I have a single quote, single apostrophe in there, I should probably do this inside of double quotes to make that easy. Or I could do the escaping here. Right? And then we can say your first initial is... and the first initial, right? So whatever they type in, we're just going to take the first letter of it, and we'll tell them how many letters are in their name. Nope, I got to click down in the typing section here. You zoom that in, type in Eric, and I get first initials E. Your first name has 4 letters. Right, so length here is telling me how many characters are in it. So if I know how many characters are in it, I know the maximum index. Now the funny thing about length and indexes, right? When we looked at Eric, right? Eric had 4 letters, and it had indexes 0, 1, 2, and 3. So you'll never have an index at the length index, right? Because you're 0 up to but not including. Right? Indexes go from 0 up to but not including the length. So if the length is 4, there is no index 4. Right? The last one is the length minus 1. So we can get access to individual characters that way. It's kind of fun with individual characters in a string. And then you can do silly stuff like, hey, let's do a string for the alphabet. We'll say, I want the alphabet is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Right? And then I can get, I don't know, we could spell someone else's name, right? Their name is equal to, we'll take the alphabet. We want index of, right? So E is the 5th letter, right, in the alphabet. So that's at index 4, right? Index 0, index 1, index 2, index 3, index 4. So I get 4 plus alphabet. Index of R is, I forget what that is. So it's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's the 18th letter, so it'll be the 17th index. Plus the alphabet index of, and then I here is 1, 2, 3, 4, 5, 6, 7, 8, 9. That should be index 8 plus alphabet index of 2, right? Because C is the 3rd letter, so it's the 2nd index. And I can print other name. And again, this is not super practical, but this is just practicing with trying to use some of these examples with what can I do with these values. Right now I got out Eric, all uppercase letters. Now, what you can't do, right? You can get individual letters, but you can't change individual letters. So I can't say, hey, alphabet index of 0, let's actually make you a Z. This is going to crash real hard if you try and change the value by index. Now, strings have this property, they're considered immutable. It means you can't change them. So even though you can access them 1 character at a time, you can't set them 1 character at a time. The string itself is immutable. You can't modify it. You get string object does not support item assignment error here. You can't assign 1 index at a time. You can get them 1 at a time, but you can't change them 1 at a time. Now you can, if you want, you can change the alphabet. We could say, hey, I want to make it lowercase. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, V, W, X, Y, Z. Right? We could reassign the value here. What's happening behind the scenes is it's not changing this value into this value. Remember, when Python runs, it has to ask the operating system. Let me try the whiteboard. You know, I feel like this was actually slowing down my stream. Let me give it a shot and see. If it gets laggy, let me know. I think one of these tools was slowing things down. Let me try it and see. Come on, whiteboard. Yeah, look at that. Wow. It hates whiteboard. That's crazy. Clear this off. Let's see, was it just at loading? Maybe it was just at loading it. So remember, when you say, hey, I want name, assign it the value of something. Eric. Python goes out and asks the operating system, right? Python goes and talks to the operating system, your OS here, and it says, hey, I need a place to store this. So your operating system sends back, oh, sure, let's save it at x37fb. And then Python takes this value and writes it to that memory address. So if I go change name, if I reassign name, if I say name, now it equals about Charnesky. It doesn't put Charnesky here. That's not what happens. It goes out to the operating system again and says, hey, I need a new location in memory. So your operating system says, oh, sure, how about you put this one at x729a? And it puts Charnesky there, and then name points at that location. So what was previously stored here, Eric, at 37FB, is gone. That'll actually get garbage collected. It'll get cleaned up. Python will say, I don't need that memory anymore, and the operating system will take it back. There's this really cool process called garbage collection that does all that for us. It's pretty handy. Okay, so we can change the values of strings, but they're immutable. It's not actually changing in the same location in memory. And the reason is because when you ask the operating system to store a string, right, this one is going to take up 26 characters worth of space. A different string might take up 100 characters or 4 characters worth. You don't have that same chunk of memory to fit the same size string, because it's not guaranteed to be the same size. And that's the reason why. Right? Other things we saw, like the string concatenation, right? You can add strings. It's not really adding here. It's taking a string and another string and sticking them together. It's concatenation. That's our term for it. So you can use the plus operator, but it doesn't actually add them. It just concatenates, right? It sticks one on to the other. Now, another sequence type, because sequence types are really handy, really useful here, is called a list. And in Python, we use these square braces. That's a list notation. So we'll say, hey, this is we'll say friends equals a list. We'll assign an empty list to friends. Okay, now I have a list. Then what I can do with it is I can start adding values to it, or I can start changing individual values, which is kind of fun. So this one is empty right now. So I can say friends dot append, and I can add something to it. So we'll add Larry to my list. I'll take friends, we'll append Vlad to the list. Right? Friends dot append, we'll add Sam. Right? So append then puts it in the last location in the list. So, and lists, you can pretty much expand as much as you want. There is technically an upper limit, but we don't really care. We're not going to hit it for our purposes with the size here. So we can add individual items to the list here. And then you can even print the list out, which is really cool. You can print your friends list. We'll run it. And you'll get the same list notation. So this comma separated with string values, right? Like I could, when I make the list, I could just give the values up here. You just comma separate them. Right? Instead of appending them, we could do either way. So usually if you know what your values are, you're going to create them here instead of appending. This is technically faster if you know what the values are. Again, we don't care too much though. And we'll get the exact same thing out. Right, so what's cool is that this looks like the list I just assigned it. Right, so when it prints, it's very literal. You get, here's the individual ones. Now, if you wanted to, once you have the list, lists are mutable. You can change what's at the given indexes. So I can say, hey, friends at index 0, let's say instead of Larry, maybe he doesn't want to go by Larry, maybe he wants to go by Lars. I'll put in Lars. So I'm going to print it before and I'm going to print it after. He actually hates the nickname Lars, but it's funny. It's funny anyway, right? So we'll see it changes the value at that index. So other things you can do with lists, right? The lists are super flexible. They're really cool. We can take friends and we can remove a given item. So let's remove Sam from the list. And I'll print out my list of friends again. Right, and you'll see Sam has been removed. You can also remove something by index if you want. So this is removing by value, remove by value, and you can remove by index. To remove by index, it's pop. Now this isn't going to make a whole lot of sense until next semester, but that's okay. You tell it what index you want to remove, and it removes that index from the list. Now, what's like if I popped off 0, everything is going to shift down back into place. So if I pop the 0th item off, the first item off, everything else is going to shift. It doesn't leave blanks, right? So it takes it out and the list is now smaller. Now what you can also do is you can get the length of your list too. So we can print the length of friends. And I can say Eric has length friends. Now this is kind of sad after I remove a couple of them, right? Oh, Eric has 1 friends. Oops, uh-oh, maybe we should add some more people. So we'll go and add some more. We'll say friends.add, add my friend Luke in. Okay. Oh, I'm sorry, it's not add, it's append. My mistake. I get confused sometimes with different lists. Right, and then, oh, sure, we added it, and then we should print friends again as well. Right, and now we see 2 friends are left in the list. So you can add values with append, you can remove values with remove, but you can remove items by index as well. Now, the other crazy thing about lists is that all of the items in here don't even have to match. So if I wanted to, I could say friends.append 100 and add an integer value. Or I could say friends.append 42.7, add a floating point value, right? Python doesn't care. It's going to be confusing, and generally you don't want to mix the types in your list, right? You want all of the types to be the same, but Python lets you do it. It's more than happy to let you put anything you want in here, any particular type. No big deal. Now, if you do have a bunch of numeric values here, let's say, hey, well, let's make a list of scores, and then I'll ask the user. I'll say, let's take scores, and we want to append an int of an input of enter the first score. And I'll just ask them a couple times here. So first, second, third score. Sure. Second score, third score. So we're going to append whatever we get back from the input that's been then turned into an integer. Then what I can do is I can say the max score is, and you can use max on a list. You can say, hey, give me the largest value in that list. Now, this will only work if all the items are the same type. Just another reason you probably want to keep them all the same type. And we'll do, how about the min score? And how about average? Now, average is not quite as easy, unfortunately. But what you can do is you can take the sum of the scores divided by the length of the scores to get an average out, right? The sum divided by the length, the number of items, is going to give you the average. So sum all by itself, it might be interesting depending on what you're doing here. Like if you're totaling up your receipts in a register at the end of the day, sure, that's probably useful. And our purpose is the sum of the individual scores on a quiz, that doesn't really matter much at all. Right? So let's run this and take a look. So again, Eric. All right, enter some scores. So how about we had a 95, how about we had an 85 and a 92? 95 was the max, 85 was the min, average 90.66666666666667. Cool. Right, so min, max, average, essentially, you can calculate it. That's cool. Other things you can do, which are really fun, is you can get a count of the number in a list here. So I'm going to say, we'll say here, count, list my scores.count of 100. People scored 100. So it's going to count the number of times that 100 occurs in the list, which is kind of fun. So Eric, 100, 195. Right? Min, max, average, and then 2 people scored 100. And we'll go through the list and see, hey, how many of these values match this one? Now this one you can do with strings as well, if you wanted. Hey, like, how many friends do you have that are named Alex? Because it's such a common name or something. And anything you want to pick there. You can do that sort of fun stuff with it. Then if you wanted to, there's also another option, although this one kind of depends on what you're doing here. We can get the index of a particular value. So we'll say score 85 is at index, and then you use scores dot index of whatever value we're looking for. All right, so Eric, so if I have 100, I have 85 and 100, it should be at index 1, right? The first 100 is index 0, index 1, index 2. So 100, 85, 100. Cool, that worked well. But now what happens if it doesn't exist, right? If we don't have an 85. Zoom in a little bit here. 100, 100, 100. We get, it crashes. Not in the list. So again, you got to be a little bit careful here. This will crash. And next chapter we'll learn a way to deal with that where it doesn't actually crash anything here. So don't worry too much about it. we can figure it out. And then if you have lists here, and again, it kind of depends on what you want to do, but this is a weird list, we'll take my friends plus the scores. I can print the weird list. So you can take one list and add another list to it. It's essentially concatenation, just like a string and a string. When you concatenate, they just get stuck together. Same thing with a list. It'll just take one list, put the other list at the end. 100, 100, 85, we don't want it to crash, right? And we'll see Vlad, Luke, the 100, 42.7, and then the scores here. So again, depends on what you're doing with the list, but you can add them together. It's kind of fun. All right, so that's some basics with lists. We'll spend more time later on in another chapter working with lists. When we get to chapter 8, we'll spend an entire chapter on lists and another type we'll talk about in a little bit here. So we don't need to get too far along here. All right, and then another type. So when we dealt with strings, right, it's a sequence type, but it was immutable, it couldn't change. A similar to a list, but is unchangeable, immutable, is called a tuple or a tuple. I think most people say tuple. Some people say tuple. I mean, it's spelled T-U-P-L-E. So however you want to say that, great. Doesn't matter too much here. This will be my unchangeable list. Uses parentheses. So the parenthesis notation will give us the tuple. Now with this one, you have to know what the values are ahead of time. Right, so you have to tell it 100, 85, 100, right? Because I can't take my unchangeable list. There is no append. Right? You can't add. There is no remove. You can't remove. You can get the index of a value out if you want, like you could. You could get the max of that unchangeable list. So it's similar to a list, but it's unchangeable, right? Actually a tuple. How about that? Is actually, there we go. Unchangeable list is actually a tuple. Uses the parenthesis notation. You can do mins, you can do maxes, you can do sums, you can do lengths, but you can't change the values. So remove, remove, pop, and append are all no good for tuples because they can't be changed. Yeah, the named tuple thing is just kind of weird. So some tools will let you do this named tuple, where you say, hey, I want a bunch of values that are going to be attributed, get to a given name here. So the example they use is like, I want a car, and then it has a bunch of values associated with it. So each car will have a make, a model, a price, a horsepower, a number of seats, all sorts of things car people care about. I'm mainly concerned if it gets me from A to B, but again, that's just me. So you can use named tuples in that sort of way. I wouldn't spend a lot of time on it. Just know that they exist. I'm not going to ask you to do them at all. Right, and then the next value, the next sequence type here is a set. So a set is cool because it only allows unique values to be added. So a set, unique values. So you probably don't want a set of scores, right? You folks would be pretty sad if only one of you was allowed to score 100. So two different ways to make sets. So we have, here's my unique numbers is a set of, and then in parentheses, you give it a list. Which is super weird, but you can, like this. So you say set of a given list. And so it'll say 100, 99, 95, whatever, 97, sure. Like that. So that will make a set. And then you can do all the things, right? You can add to sets. You can remove from sets. Don't think, so there's no append, which is weird. This one's called add. I don't know why. It's just a little confusing here with sets. Again, so if you want them to be unique, you use a set. The other notation you can use, which I actually find kind of confusing here, so this is other notation set, is going to be curly braces. And we'll say, hey, I want 1, 2, 3, 5, 8, 11, no, sorry, 13, 21, right, on and on and on. So you can use this curly brace notation, right, and then you get this add options. You can remove, you can update's not anything we're going to do here. A couple other cool things, but sets force them to be unique. Now, what's weird about sets, so sets are, this notation is actually considered a dictionary. We're just not having associated values, so it's a little confusing here at first. Don't worry too much about it. But if you want to change the value here, we need to go remove the existing one and then go add it. So we don't get at things by indexes. So sets don't have indexes. So, and sets are technically unordered. There's no, just because we put them in one order, doesn't mean we're going to get them back out in an order. So there's no guaranteed order here. Now, they'll print just fine, right? When I print my unique numbers, it should print okay. And I can print my other notation set here, and they should look fine. We're going to get this square brace notation out. It'll be interesting. 100, 85, 100. I'm sorry, we'll get the curly brace notation out. So here's the set, right, that we added here. And if you try and give it a duplicate value, try and put in another 95, it's going to be upset with us. 100, 85, 100. Oh, I'm sorry, it just ignores it. Sorry, it doesn't get upset. It just ignores the duplicates. So you notice here, like, we already lost our order. We put them in this order, 1, 2, 3, 5, 8, 13, 21. And when we got it back out, it's in a different order already. So depending on what you want to do with your values, a set might be useful, right? You can remove, you can add. I don't know that number. I don't think it's any of you folks. Yeah, I don't think it's any of you folks. So sets are cool because they are unique. And once you have unique values, you can get the intersection of sets, right? Which is the values that are in common. So you can say, hey, I want all the common values between this set and this set. Or you can get a union of them, which will give you all the values from this set and all the values from this set with a unique, right? You can get the difference, which says, okay, take me all the values in this set and take away anything that exists in the other set. So it's only what's not in the other set, which is fun. You can even get a symmetric difference, which gives you only items that are in either this set or this set. Again, there's special cases for each of those, which can be kind of fun. But sets do a lot of interesting things if that's what you need. Just kind of keep that in your tool bag. We're not going to use them a whole lot because more common we're going to use this dictionary here. And a dictionary is similar notation to sets. And that's why I think sets are a little confusing, probably because I'm more used to dictionaries. But what a dictionary does, it's sort of, the name of it hopefully helps kind of understand what it is. When you use a dictionary, you say, okay, I want to go find a word. And you pick whatever word out of the dictionary you want is, and the value associated with that word is its definition. Right? So you get a value, or we're going to call that a key, that you're going to look up on, and you get an associated value. So with a dictionary, it's the word is the key, and the associated value is the definition. So it creates a pair. So key and value. Key value, we'll call those mappings, right? It's a mapping type. It says, hey, this value is associated with this key. Okay, so when you make a dictionary, you might say this is, let's do student scores. And you use the curly brace notation, but now what you give it is key value pairs separated by colons for key and value. So you get key, colon, value, comma, and you just separate key value pairs here. So I might say, hey, the key might be your name. So let's add Eric, and let's say my score here then is 100. And then we can add Larry, Larry is only getting a 95 maybe, and then we can add Vlad. We'll say Vlad, maybe he's getting 100, and then I'll add Luke. Maybe Luke's only getting an 80. Oops, end the quote there. So it's key, colon, associated value when you create dictionaries. Sorry, it doesn't like all my spaces here. Okay. So those little squiggly lines here are just warnings. They're not errors, but we'll try and clean those up so they're not distracting. Right, so you can have a key and an associated value. That's called a dictionary, which is really fun. Now, to get values out of a dictionary, I can just print the student scores here, and it's going to print a lot like what it looks. Again, the order is not guaranteed with a dictionary. 100, 85, 100. There we go. So we get out just what it looks like. Key, colon, associated value. Key, colon, associated value. But what you can do with it then is if you want to get an associated value, we can say, hey, the score for Eric is... Now, this is where it gets really silly. You use the dictionary name. So this is my variable name for the dictionary. And then I say key of, and you give it the key value that you want to look up. And what this is going to give you back is the associated value with that key. So it says, hey, dictionary key of Eric has what associated value. So you have to know the key to get the value out, right? Because it's a lookup. So like with the dictionary, you can't just read through the dictionary and find the definition you want and know, oh, that's the word for it. I mean, sure, technically you could. That would just take you a really, really, really long time. So you said, oh, okay, but I go look up Eric and tell me what score Eric has. So this is key of, so I could say, you know, my variable name, key of, right, for this notation, where when we talked about lists, it was like index of, right? So this was list index of 0. So it's the same square braces, but it goes from index now to key of because we're working with the dictionary. So just like sets here, there is no order guarantee, and you can only have unique keys. Now, what's cool with the dictionary, if you want to add more items to a dictionary, you just say students scores, key of, well, let's add, oh, we had Sam. Well, and we say, okay, key of Sam, Sam gets 100. So to add an item, you say, okay, here's the key, here's the associated value. Now, the catch to that is it's also an update. So if I had a second Eric in the class, and I wanted to say, hey, Eric, that Eric has a score of, I don't know, let's say 75, it's going to go update mine. It's not going to add a new one here. So because you can't have duplicates, hopefully that kind of triggers, oh, if you'd want to go and add, it's really going to do an update instead. It's going to take a little bit of getting used to. Don't worry about it. Don't worry too much about it, though. We can print them out again, and we'll see all the scores there. So see, here's the original list, and then I went and added Sam, and then I updated Eric to 75. We can see the individual scores, like that. So it's an add or update. You can delete as well. The two ways to delete student scores, you would call, oh my goodness. Why am I not remembering here? The way the book shows you is the ugly way. You could say pop, right? Pop Eric. I think pop is our preferred way here because this is follows I don't know. Again, it's by key, which is a little funny, but everything's done by keys. Yep. So pop will remove an item by key. The other way you can do it here, the other notation, uglier, right, is you say delete or del student scores key of, let's remove Vlad maybe. So I'm not a fan of this delete notation. I much prefer the pop notation. But again, that's just me. It's a little more conventional. 100, Oh my goodness, I didn't type in a number and I got an invalid literal here. My mistake. Let me try that again. Eric 100, 85, 100. There we go. We'll see after we remove Vlad and remove Eric. We popped Eric out to remove it, right? That's the easier way to go about it here. All right, so a quick little summary of all the types that we've gone through so far, because we've done a lot, actually, right? We've done ints, right, or integers, whole numbers. We've done float, right, which are numbers with decimals, essentially. We've done the char type, right, which is a single character. That is taking the numeric value, right, can take a numeric value and turn it into, or that Unicode value, right, or ASCII value, and turn it into a character. We have looked at, and then, so those are all like the numeric types, essentially, and then we have sequence types, right, which is a string, is our sequence type, right? That's just a bunch of characters. And you can get at them by index, but they're immutable here, right? So there are sequence types that are immutable. Immutable? I think that's the right. Let me just make sure I'm saying that right. Immutable, yeah, unchanging, immutable. There we go. Cool. So a string is immutable, and then a tuple, right? Or you might say tuple, however you want to pronounce it. Tuple or tuple, right? It's a sequence type that's unchangeable, but it can hold anything. And you use the parentheses to create it. Right? Strings you just use or apostrophes to create. Those are the immutable sequence types. And then the mutable sequence types. Maybe we tab that in one here. Right, try to make that look a little bit nicer. Right, is our list. So that's our sequence type order matters. And append, remove, pop, right? All those sorts of things here with the list type because they're mutable here. And then you have a set where order doesn't matter, unique values only. And then you have the dictionary, which is the mapping type, key and value pairs. Okay, so a lot of different types we've talked about already. These types like sets, dictionaries, tuples, you might consider them a container. Hey, do you need some? No, I don't. You had it out on the front porch, right? Did you go grab it after that?
It's not there.
You want me to print it again?
Mm-hmm.
All right, give me a second. All right, I gotta print my daughter's lesson out real quick. Give me just half a second here. She lost it somewhere. Be real quick. There we go. Just gotta go find it in my email. Come on, Gmail, cooperate. There it goes. All right, and let's hope the printer has ink, right? It's 2021 and printers are still hard, which is so weird. All right, I think that went. The print? No, yeah, printer's thinking about it. Cool. Sorry about that. So of our different types, these lists and tuples and dictionaries can also kind of be thought of a container. Right? It can have multiple values, really, of any type. Tuples, lists, sets, dictionaries. We can put any types that we want in there. So like it can contain a bunch of other values as you go. All right. Awesome. Yeah, cool. I think we're doing pretty good. So we got a little bit of time left, but I think we want to save the rest of chapter 3. Got jammed. Hate printers. So I think we'll save the rest of chapter 3 for Thursday, and then we'll talk about the first individual project that you'll be working on. All right. So unless you have any other questions or concerns, we'll call it a day, and I'll archive this out to YouTube for you, and we can go from there. Thanks, folks. You take care.